Yo, welcome back to the Tuesday IXL Khan Academy tutorials. Today, I don't know. Academy.
It's still same.
It's yeah, I know. And it's 7th grade. So,
Yes, ma'am.
we're about to do this today's lesson. So, we're gonna do 7th grade first, then 6th grade. No, I'll do 5th grade. I'm sorry. We're gonna do the 5th grade. So first, we're gonna start with this 7th grade lesson right here, because we're gonna do at least 3 lessons for each. So first, we're gonna do constant of proportionality from graphs. I'm gonna tell you how to do it because that's what 7th graders first do when they learn about it. So it's 4 questions, and let's do it. It says the graph below shows a proportional relationship between x and y. And make sure to like and subscribe and comment and turn on post notifications. It says the graph below shows a proportional relationship between x and y. It says what is the constant proportionality of yx? So let's just look at this graph and determine the graph. We have like a coordinate right here. And there's a 1 on on the x-axis, and there's a 4 on the y-axis. So we see right here that this point is indicating the 4, and it seems like the line is going up, which shows the variety or the variance of data that is pointing up to compound these events. That probably doesn't make sense, but okay. Anyways, this will be 1 and 4. So the constant proportionality for yx is 1 and 4. I think I'm wrong. Yep. We're gonna show a step if anybody else got it wrong. Okay. It says we can find the constant proportionality by finding the value of y when x equals 1, y equals 4 when x equals 1. The constant proportionality is 4, 1, or just 4 because it's a whole. We're gonna get 4. Nice work. So if you think it was 4, then you're goated. It says lines A, B, and C show proportional relationships. Which line has a constant proportionality between y and x of 6? I'll write this again. Lines A, B, and C show proportional relationships. It says which line has a constant proportionality between y and x of 6. So if we could see here, remember, y and x are our 2 axes that make up the coordinate plane. Now, let's see. We have 6 right here, and the C is pointing up to the 6. So that means our constant proportionality for 6 is C. Oh. Oh, we're not talking about on the x-axis. That's my fault. I'm so sorry. We'll do another one because we're definitely gonna get it right. It says, what is the constant proportionality between y and x in the graph? So we have 4 here, and the line is going up. And so our coordinate point is directly on the y-axis, and it is 4. So when we have our 4 right there, points exactly right there. So that means our constant of proportionality would be 4. This is what is the constant of proportionality yx. So now the line going straight across of the coordinate graph or coordinate plane is directly pointing to the y-axis. See, we have our numbers, so I'm going to read the x-axis first. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. You get the pattern.
Small doo-doo.
0.5, 1.5.
Somebody smell like
It's all the same numbers, exactly.
Somebody smell like
So, our answer, the constant of proportionality for yx is 1. So we're going to put 1 for our constant of proportionality. There we go. So if you did think of this different answer, like I keep on saying, then let's see. We can find the constant proportionality by finding the value of y when x equals 1, y equals 0.5, or 5/10 when x equals 1. The constant proportionality of y-axis, which is y-axis and x-axis, y-coordinate, x-coordinate, is 0.5 or or 5/10 wholes, or just 5/10. I didn't know that. That was my mistake. I gotta keep on the y-axis, because I guess the y-axis shows everything. So technically, when we go first, we have to pay attention to our numerator. I assume you have to always pay attention to our numerator, guys. I know. I got a 1, 4. Yeah, whatever. Fuck you. Okay. Yeah.
Demonetized.
I'm not gonna put it on kids anyway. So.
Demonetized. You're getting demonetized.
You're
getting demonetized, and I'm gonna get you demonetized. I'm gonna report your video on purpose.
I'm gonna put
report your video.
I'm gonna put it on ages 14 to 16-year-olds.
So, I'm gonna report your video.
Anyways, I attempted this. Yep. Okay. Which equation has a constant proportionality equal to 5? Yep.
Jamar.
Yeah, I know that.
So I'm gonna. And I'm gonna get you.
Please. Never mind. Never mind. No. So which you're my sister back there. What? Okay. Which equation has a constant proportionality equal to 5? We're gonna read our answer options. So we got A, B, C, and D. So we got A y equals 5x. We got B, y equals 10/5 x. We got C, y equals 5/25 x. And we got, lastly but not least, D, y equals 1/2 x. So we're gonna go up to our first option, which is this. Of course. What is the constant of proportionality in the equation y equals 3x? So, y equals 3x. We don't know what our constant proportionality is, but I'm guessing it's 3? Or do we need to... Oh, it is 3. Okay, sure. Okay, it says which equation has a constant proportionality equal to 9? So we're gonna look through all our answer choices. We got A, y equals 81/3 x. We got B, y equals 9x. C, y equals 3x. D, y equals 1/9 x. But wait, before you put your answer choice, please pay attention to this. Okay, let's go. So we're just gonna use a black marker, obviously, and we're just gonna put this down. So we're gonna pay attention to these two Do I even have it on? No. We gotta pay attention to the X axis and that's terrible, and Y axis. So always gotta pay attention to those. We know that we have a 9 over here. That 9 up there. So we're gonna make a little graph showing what we got. And we're gonna, what am I supposed to write? And we're gonna put our little graph. Oops. Gonna put our little graph right here. So one side, one side will be the X. Oh, this is so terrible. One side will be the Y. We gotta count by 3. So it's gonna be 3, 6, 9, 12.
I'm gonna put my little thing
15,
my little air purifier.
18, 20, 23. But we gotta look through something. We gotta either look through the X-axis or the Y-axis. Gotta either look through the X-axis or the Y-axis. We know which one to look through at, and which one to look at will be the X-axis. We know that our X-axis has the first number we need to look for. The second number we need to look for, which is which is 9. So our answer, y equals 9, which is our constant proportionality, is y equals 9, x. Yep. That's how we do it in here. That's how we do it. Yes. Okay. What is the constant of proportionality in the equation y equals 1/2 x? So this is our last question. And we need to know, but obviously this is 1/2. So we're gonna go for our last lesson, which is we're gonna learn about probability. And the probability is the most hardest one to do, because there's one called theoretical probability and and experimental probability. Those ones are very hard. So anyways, Bruce is you might need a calculator. You might need a calculator for this, so you can grab a calculator. You might need a calculator. Alright. Bruce is going to call one person from his contacts at random. He has 25 total contacts. 20 of those contacts are from his neighborhood. What is P, which means probability? Call a person not from his neighborhood. If necessary, round your answer to 2 decimal places. So, we're gonna put our calculator to the side.
What you mean every single day? You know that the water bill is high. But I'm turning the water off when I'm in there. It's not true. I'm doing start turning the water off.
We're gonna put our calculator to the left. And so, it says he has 25 total contacts. Tell me if those contacts are from his neighborhood. What is P? I'm gonna just put. Your answer should be an integer like 6 and exact. Honestly, I don't really know what probability is. I actually forgot. We're gonna look at the steps. It says probability equals number of favorable outcomes and number of possible outcomes. And it says there are 5 favorable outcomes. Favorable outcomes. The 25 minus 20 equal 5 people not from his neighborhood. There are 25 possible outcomes to 25 total contacts. P, call a person not from his neighborhood. 5/25 equals 0.2. So we're gonna do 0.2 or 2/10. It says you randomly draw a marble from a bag of marbles that contains 3 blue marbles, 4 green marbles, and 5 red marbles. What is P? Draw a blue marble. If necessary, round your answer to 2 decimal places. Uh-oh. It's not gonna be good. And now we're getting to 6th grade in a minute, but if you're still watching, like and subscribe. If you want more tutorials like this, you probably don't, but I'm still gonna do it anyways, because people might need help passing the Georgia milestones, and I'm not giving enough example. So we're gonna read the question one more time so we can fully understand this situation. You randomly draw a marble from a bag of marbles that contains 3 marbles, 4 green marbles, and 5 red marbles. What is P? Draw a blue marble. If necessary, and your answer to 2 things. So I think we're gonna at least add 3 plus 4 plus 5, which equals 12. And 12 minus 0.2 equals 11.8. So 11.8 with the P equals, that won't make sense. 8. So it's 11.8. Maybe. Hold on, you guys. Yeah. Anyways, it's definitely, we're gonna show a step. Remember, probability, number of favorable outcomes, number of possible outcomes. I did that. There are 3 favorable outcomes to 3 blue marbles. There are 12 possible outcomes to 3 plus 4 plus 5 equals 12 total marbles. P, which is probability, draw our blue marble, equals 3/12 equals 0.25. So this will be 25 hundredths. Not these. You spin the spinner shown below once each sector shown has an equal area. What is P? Beaver. If necessary, round your answer to 2 decimal places. So, remember, probability equals, we can't do this anymore. But it seems like we got sum of turtle, sum of otter, and beaver. And the P, what is P? It says it's beaver. I'm not really so sure what this should be, but the example is really showing me. You should have a fractionative answer. So beaver should be something like 1/4, 1/5, or like multi-digit fraction. I'm sure the steps how you should do it. Favorable outcomes, possible outcomes, ability. There's one favorable outcome, the one sector with a beaver. There are 3 possible outcomes, since there are 3 equal sectors. P, probability, beaver, 1/3 equals 33 hundredths. Dang, I'm so sorry, you guys. But now we're going to move on to Ram. Hold on. Oh, and we might have like a middle school physics tutorial, and we're gonna watch this video of Sal and Iman or whatever, and we're gonna do that. We're gonna do that. It's gonna be a tutorial. It probably might come out like 2 months or 3 later, 2 months or 3 months later, but that's gonna be Monday's tutorial. It's only gonna be, not for Monday, for Friday. So now we're gonna do 5th grade. Now we're gonna do, people mainly struggle on fractions, decimals, and coordinate plane. So we're gonna do each of a lesson with coordinate. So first we're gonna do coordinate plane, then we're gonna do a powers of 10 lesson, then we're gonna do decimals, then we're gonna do fraction, and then it's gonna be the end of this video. So first we're gonna start off easy with graphing points on the coordinate plane. So let's go. So let's plot 1 and 6. So our 6 is gonna be right here. We're gonna move it right here, and then we're gonna check it, and then we got the answer right. We're gonna plot 7 and 0. Oh no, I'm not stupid. It's at 7, 0. Step. Oh, I forgot. I totally forgot. I had learned this when I was in 5th grade. Oh, shoot. I am so stupid. It's my fault, guys. So now we're going to plot 8 and 9. So we're going to pay attention to the x-axis and the y-axis. So first, we have 8 and 9. We are going to go further on the x-axis. We're going to move up to the y-axis until we see 9. And then right here, this is the origin. So first, let me tell you the parts of a coordinate. Of a coordinate plane. Of a coordinate graph or coordinate plane. So this is the origin, which is the 0 or the origin on the graph, which makes the spot. The x-axis or the x-coordinate in the x-coordinates is where we have the numbers on down. And the y-axis, y-coordinates, where we have our numbers on the top, on up. So we have to pay attention to this graph. Up and down is how we pay attention to our coordinate planes and graph. Remember that when 5th graders that are watching. When you get to 6th grade, it's gonna be more in depth. In 7th grade, you learn the same thing. 8th grade, so on and so on. Coordinate graphs are very important for plotting exponential, like economical data and some other stuff. So we're gonna check, and I go. Of course, we're gonna try. Oh, right here, we got 0 and 4. We're gonna move down. And then we're gonna have the 4. The 0, which is the origin, we're gonna move it down to the x-axis, x-coordinate, and we're gonna move on to 4. We got the 0, the origin 4, the 4. So we're gonna check. How was that wrong? Oh, I know I did wrong. So I was supposed to go down, then up, because our origin, our 0, if you got confused, is right here. So I'm done. I'm so sorry. 9, 6. I want to make sure we're going up to the y-axis, y-coordinate. So we got our answer. Got the answer, so forth and so forth. That wasn't really so good. But we're gonna go to this. We're gonna do powers of multiply and dividing by powers of 10, which is the most easiest thing, but this is what people struggle on. So we're gonna get ready to practice. This is 7 questions, easy questions. So complete the equations with the powers of 10. Now this might be tricky, but with the powers of 10, we got this. So this might be 10 to the 5th power. because the 10 equals 10. No, I'm gonna name all the powers of 10. 10 equals 10. 10 to the first power is 10. 10. 10 to the second power. Oh, I'm sorry. 10 to the third power. 10 to the second power is 100. 10 to the third power is 1,000. Yep, 10 to the third power is 1,000. 10 to the fourth power is 10,000. So we're on 10 to the third power, 10 to the fourth power, and this will be 10 to the fifth power, which I think is 1,000. I'm not sure if this is actually right. Yep. Of course I'm wrong. Let's see what else we could do. We could do introduction. Because I'm sure everybody has not been learning about powers of 10 yet. Powers of 10 is the position or where it's like the place value that goes left to right. So we're going to do this quick, which is equivalent 10 to the fifth power. This is 100,000. Yes. It says use the cars to create an expression that is equivalent to 10^6. 10^6 is equal to 1,000,000 to 6 power 9. We're gonna make an equation. 10 times 6. It's just oh, I'm sorry, we're not gonna use that. So we're gonna use this as multiple times. Because we're gonna.
Jasmine, what you doing? What are you doing? That thing flooding again? Oh, it's stinking here. Yep, it's flooding again. Like you're doing too much. Yeah, that damn water out there running again.
Sorry, guys.
Yeah, stop.
2, 3, 4. 1, 2, 3, 4, 5, 6. Can I take this out for a sec?
What?
Can I take this out for a sec?
For what?
Because I was still recording.
Okay.
Go, Quez. Dude, you can see the speed of Quez walk-ins is going to help us out tremendously. I
Looks
made
like this is
one
wrong.
really dumb decision in this game as to why this is a game. But I still definitely feel like this was a win performance-wise. Or no, Washington.
Multiplying decimals. We're gonna multiply decimal times. This is definitely easy as heck. Let's see if it can meet 2 skills at least. So it's just like regular multiplication, but it's with decimals.
Hey, imagine I lose this.
So what is 9
Just
times
because I keep
6?
fumbling. Oh my goodness.
9
Okay,
times
stop running into
6
this,
is 54.
please.
So
I
we're
need
good with that.
to pick to end this thing. This guy's all of a sudden just turning into the goat.
But it's gonna be 54 hundredths. So we're good. Alright. What is 6 times 6? Or 6 times 6 times? Remember that 6 times 6 is 36. So that means
Okay,
in decimal
this is too
form
close.
it's gonna be 3600. So anything that you see that looks familiar, that looks like it was already in multiplication, you can turn it into decimal form, which gives you 36 hundredths. Gonna find out what 2 times 3 times. So 2 times 3 obviously is 6, and then we're gonna turn it into decimal form, which is 6 times. Oh, this is what we're gonna do here. I forgot.
Take our win and see another day. Stop fumbling.
And the reason why is that you guys might be confused is because we see 2 of that. We see 2 of those zeros, which makes it into. So whenever you get confused within that, check out this tutorial if you just joined, or you know, during the premiere or during this premiere and all that. This is gonna be 54.
Take 3. That was a drop. That's just a drop. Take 3.
This is gonna be 40.
Okay, that's fine. 10-point lead should be okay.
It's gonna be.
Okay, 3 beats this guy. Way to be. Dude, he had a crazy game. Okay, get out of here. Forget the fact that this got close. It should have gotten close. Get out of here with the win. GG.
Oops. This is gonna be 25, I guess.
Well transferring. There it is. There it is. Okay, that was cool. GG's, man. Oh, good game. Ladies and gentlemen, that was a good week and a bad week. It's so like...
You can also watch the video for understanding too. So I'm gonna watch the video so how you can.
Let's say I want to multiply 3 point or fractions and then multiply. Let's say I want to multiply 3.1 or 3 1/10 times 2.4, which could also be described as 2 4/10. So pause the video and see if you can do this. And once again, I'll give you a hint. See if you can express these as fractions. So there's a couple of ways you can express it as a fraction. You could express this as 3 1/10 times 2 4/10. 2, same color. 2 4/10. Now whenever you're these are mixed numbers right over here, and mixed numbers are not super straightforward to multiply. It's easier if they were written as what's often known as improper fractions, but essentially not as mixed numbers. So 3 is the same thing as 30/10. So 30/10 plus 1/10, this is 31/10, times 2 is the same thing as 20/10. So 20/10 plus 4 is 24/10. 24 over 10. And hopefully this makes sense too, that 3.1, this 3 right over here, this is 30/10, or I could write, well, let me write 30/10, and then this is 1/10. So this total is going to be 31/10. Likewise, this 2 is 20/10 plus 4/10 gives us 24/10. And now we can multiply. So this is going to give us, our denominator is pretty straightforward. 10 times 10 is 100. And then 31 times 24, we can multiply it in the traditional way that we're used to multiplying two-digit numbers. 31 times 24 is going to be equal to 4 times 1 is 4, 4 times 3 is 12. Now we're going to be multiplying in the tens place. We're going to put a 0 here. So 2 times 1 is 2. We're really saying 20 times 1 is 20, but you get the idea. 2 times 1 is 2. 2 times 3 is 6. Really 600 because it's 20 times 30, but I'm just following the standard the method for multiplication. And then you add these, and you're going to get 4, 4, 7. So when you multiply these two things together, in the numerator you get 744 hundredths, which can also be expressed as, this is the same thing as 7 hundredths over, or 700 hundredths, I should say, plus 44 hundredths. And 700 hundredths, well, that's just going to be equal to 7. So this is 7 plus 44 hundredths, which we could write as 0.44. That's our 7 and 44 hundredths. And we would be done. And you might already be seeing a pattern.
Did you hear me?
If you just took 31 and multiplied by 24, you get 744. And notice, I have 1 and 2 digits behind the decimal point. Notice I have 1 and 2 digits behind the decimal point. And so think about whether that always works. Think about and why that might work. If you just...
Okay, you guys, this is going to be the end of the premiere for the tutorial. We did it on Khan Academy. We did do 7th and 5th grade today. Remember, in 2 to 3 months, we're gonna do middle school physics, technically science, soon. So I hope you enjoyed this premiere. Make sure you like and subscribe to ATL Plays YT for more tutorials like this. And bless you guys. Have a good rest of your day. And see you on next Tuesday. You already know. Peace.